Welcome viewers, welcome to the new lesson from Dr. R's Biology. If you did not subscribe the channel, you can just click on the subscribe button and bell icon. Welcome dear students. So far we have learned about the different types of monosaccharides and their features. Now we are just moving into different types of glycosidic bonds. First of all, we can define glycosidic bond. So glycosidic bond is nothing but the covalent bond. So it's a covalent bond. The covalent bond which is actually utilized by the carbohydrate molecules in order to link themselves in order to form the polysaccharides or oligosaccharides, etc., or in order to link with another molecule to form the carbohydrate derivatives like glucosamine, nucleoside, etc. So that covalent bond is actually known as the glycosidic bond. So we can just define it like this. Glycosidic bonds are the covalent bonds using which carbohydrate molecules link themselves or with other molecule to form oligosaccharides, polysaccharides or carbohydrate derivatives. So that bond is actually the glycosidic bond. So this will be used to link with the carbohydrate itself or to link other molecule. If it is linking with the carbohydrate itself, what will be formed? Either oligosaccharide or polysaccharide will be formed. If it is linking with the other molecule, carbohydrate derivatives will be formed. What are the examples for carbohydrate derivatives? You can see that amine derivatives are there, just like galactosamine, glucosamine, etc. And then you can find the nucleoside. So that is actually meant by the glycosidic bond. Now, which carbon in the carbohydrate molecule, the monomer or monosaccharide molecule, is actually involved in this particular bond formation? Mostly it will be the anomeric carbon. In most of the cases, anomeric carbon will be linking with the hydroxyl oxygen of another carbohydrate molecule. So link with the hydroxyl oxygen. So if you are just taking, I am just representing that. So this carbon, this is anomeric carbon, it will be linking with, there is another carbon there, and there will be OH group there, and this oxygen, so oxygen of the hydroxyl group will be linking with this carbon. So this is how most of the cases, in most of the cases, this particular glycosidic bonds are formed. But that is not the case always. Instead, the other carbon can also get involved in this particular process, especially when the carbohydrate derivatives are formed. Just like if you are just thinking about the glucosamine, we can see that the second carbon is involved in bonding with the nitrogen. Okay, so in most of the cases, anomeric carbon will be linked. In other cases, there are cases in which the other carbons are also involved in the formation of glycosidic bond. Now, based on, so hope you have understood what is actually the covalent bond and what is the importance of covalent bond. Now let us see what are the different types of covalent bond. There are main classification is based on in which atom or molecule is involved. So let us see what are the two main types of glycosidic bond. there are mainly two types of glycosidic bond. The first one is the O glycosidic bond. So first glycosidic bond is the O glycosidic bond. So O glycosidic bond is defined as, in the previous case as I told you, the oxygen atom of the hydroxyl group will be involved. So if two molecules, if two carbohydrate molecule or one carbohydrate and other molecule is linked through oxygen atom, it will be known as the O glycosidic bond. If two molecules were, at least one molecule is carbohydrate, is linked through oxygen, then it will be known as the O glycosidic bond. Okay, so in this case, the O glycosidic bond is further classified into four subtypes. Okay, based on the anomeric state of individual component in this particular bonding. Okay, let us see. There are subtypes of O glycosidic bond, and the first subtype is, we can see that the alpha glycosidic bond. Alpha glycosidic bond. You have to keep in mind, most of the cases O glycosidic bond is actually meant for the polymer formation of carbohydrate, just like oligosaccharide and polysaccharide. So in alpha glycosidic bond, both component or both carbohydrate unit will be in alpha anomeric configuration. We know alpha anomeric configuration is nothing but if the anomeric carbon hydroxyl group is below the plane of the molecule, it will be alpha, and above the plane of the molecule, it will be beta. Okay, alpha glycosidic bond example is the glycosidic bond that is present in case of maltose. In case of the maltose, let us see how this alpha glycosidic bond is going. Now, in case of the maltose, it is alpha 1,4 glycosidic bond. So in case of the maltose, it is alpha 1,4 glycosidic bond where both components are in alpha configuration. So what are the components in maltose? It is nothing but 2 glucose unit. Okay, so 2 glucose units are actually linked with the help of alpha 1,4 glycosidic bond, and that is an example for alpha glycosidic bond. Okay. Now, where you found this maltose? Maltose is actually the hydrolysis product of starch, glycogen, etc. So, it's a disaccharide which is formed when the hydrolysis of starch and glycogen take place. Okay, so maltose, let us see. So glucose units are the 2 glucose units. I am just drawing 1 glucose unit, and in the ring structure, and we know that this both are in alpha configuration. So this one is alpha glucose. So we have to draw this particular thing, OH down. Okay, OH we have to draw down, and then the remaining portion as we have learned. So the first carbon, second carbon HOH, third carbon OH, fourth carbon HOH, and the sixth carbon is there, and fifth carbon fifth carbon OH is utilized for this bond formation during ring. Now this will be combining with another glucose molecule, and this carbon, which is actually the anomeric carbon, will be linking with the hydroxyl oxygen of the next monomer. So now let us see one more. So you are having one more glucose. Okay, so one more glucose units are there that are also in alpha configuration. HOH, H, this is OH, then H, O. I'm just using hydrogen with the red so that we will understand when water is released. HCH2OH, H. So this is also another alpha glucose. So this is alpha glucose and this one is also alpha glucose. Now let us see, this carbon is actually making bond with this particular oxygen. When that bond is formed, this OH will be released from this carbon and this hydrogen also will be released from this particular hydroxyl group. Okay, so we can see that a water molecule will be released out. Okay, I am just drawing this portion only. The remaining portion is exactly same. I am just drawing the portion which is important and which is to be marked. Okay, for your examination you have to draw the entire structure. It's easy to draw, nothing to worry. Whenever we are seeing the chemical structure, normally we will be worried about it. Nothing to worry. We know that how we have drawn this particular ring structure. If you are knowing that particular glucose linear structure, and if you don't remember the linear structure easily, you can just watch my video how to remember the monosaccharides. Okay, so it's easy, nothing to worry. When you are worrying, you will not be getting it. Okay, I'm just drawing this particular thing. So we will be having, so one water molecule is released and there will be H and that will be linked with the oxygen of this hydroxyl group, and you know that this hydrogen is there, so hydrogen, and it will be looking like this. So oxygen is there. So remaining component you can just fill. Okay, so this is actually the maltose with the alpha 1,4 glycosidic bond. So you have to keep in mind that this particular glycosidic bond, different types of glycosidic bond is important for the 4-mark question. It will be coming, almost 90% it will be coming for this year examination, this semester examination. So this is important. This is one of the example, alpha glycosidic bond. Okay, there are alpha 1,6. So based on the number of carbon in which it is involved. So here we can see that this is the first carbon and this is the fourth carbon. That's why alpha 1,4 linkage. It can be alpha 1,3. It can be alpha 1,6. When we are learning the polysaccharide structure, we will be just learning the branching. At that time, we will be just seeing the alpha 1,6 linkage. Okay. Now let us move to the beta glycosidic bond. Okay. So first one was alpha glycosidic bond. Now we are just moving into beta glycosidic bond. So beta glycosidic bond. In this beta glycosidic bond, both components will be in beta configuration. So if both components are in beta anomeric configuration, so if both components of this particular glycosidic bond are in alpha beta configuration, it will be known as the beta glycosidic bond. The best example is the cellulose. Are you familiar with the cellulose? You have learned it in grade 12. Cellulose is nothing but the hydrolyzed product of cellulose. So it is actually forming from hydrolysis of cellulose. Hydrolysis of cellulose. Okay, so this cellulose will be in beta 1,4 linkage. Okay, beta 1,4 glycosidic bond. Beta 1,4 linkage, otherwise known as the beta 1,4 glycosidic bond. Okay, beta 1,4 glycosidic bond. Cellulose beta 1,4 glycosidic bond. So what are the components in this particular thing? Nothing but 2 glucose unit. So 2 glucose units are linked with the beta 1,4 glycosidic bond to form the cellulose, which was actually the hydrolyzed product of the cellulose. So let us see the structure then. So we have to draw the glucose. So first glucose. Okay. And we know that it is in beta configuration. So OH should be on top. I am just drawing OH with the red to understand what role is. And the remaining portion as such, whatever we have learned, HOH, then OH, H, OH, CH2OH, H. Okay, this is now linked with another glucose unit, which is also in alpha beta configuration. CH2OH, H. So here this particular hydrogen will be released. So I am just representing this with the red one. As a result, what will be forming the same way? Water molecules will be released. H2O will be released, and that H2O is nothing but the hydroxyl group of the anomeric carbon and hydrogen from the hydroxyl group of this particular carbon. So this is the first one and this is the fourth carbon. So as a result, the bond will be formed. So I am just drawing the part where bond is formed. Okay, so here we can see that the bond hydrogen is down and the carbon will be forming bond through in this way, and the oxygen is here. So it will be having a reverse bonding. It's not looking like the same as alpha 1,4 linkage. Instead, it will be looking like this. Oxygen. So hydrogen will be there, hydrogen will be there. The remaining component you have to fill as like what we have drawn here. So this is actually the beta 1,4 glycosidic bond. Okay, you can draw the same in this way also. So I am just drawing the bond only here. Hydrogen, oxygen, hydrogen. So you can just draw the same thing in this way also, no problem, or in this way. Both are correct only. So this is actually the beta glycosidic bond, where beta 1,4 glycosidic bond is actually linking to glucose molecule to form the cellulose. So this is the second type of glycosidic bond. Okay, so now we can move to the third and fourth type of glycosidic bond. Okay, as we have already learned how to draw the bonding and all, so in order to save the time, I just drawn every figure for the third type of glycosidic bond. So I will be describing what it is. As you have already learned how to draw, I have already done it. That's why. Otherwise, I will be showing it. Okay. So the third type of glycosidic bond is nothing but the alpha beta glycosidic bond. From the name itself, you can see that alpha beta. The first component will be alpha. The second component will be beta. So alpha beta glycosidic bond is the covalent bond between two carbohydrate units, where the first carbohydrate is in alpha anomeric configuration and the second one is in beta anomeric configuration. Okay, so the best example is the sucrose. So sucrose, we are familiar with the sucrose, that is actually the common sugar, the table sugar. And we can see that in case of the sucrose, the glucose unit is combined with the glucose in alpha configuration, and that too in the first carbon is glycosidically bond with the fructose, which is in beta configuration, and the second carbon of the fructose will be involved in the bonding formation. Okay, so this particular sucrose is actually a non-reducing sugar. What is meant by reducing and non-reducing sugar? If a sugar is capable of reducing any other ions, you can see cuprous, cupric, etc. If it can be reduced, then it will be known as the reducing sugar. When a sugar can act as a reducing sugar only if the anomeric carbon is free. If the anomeric carbon, that means this particular carbon or this one, if that particular thing is free, it will be reducing sugar. Why only that particular thing? Because that is actually the reducing end. So reducing sugars are nothing but the sugars whose anomeric carbon is not involved in bonding, it is free. That is what actually mean by the reducing sugar. Now, the sucrose we have told it is as the non-reducing sugar. Because we can see that in case of the fructose, second carbon is the anomeric carbon, that is a functional group carbon. In case of the glucose, first carbon is the anomeric carbon. We can see that the alpha 1, the first carbon, and beta 2, the second carbon, is involved in the bonding. So, in the sucrose molecule, there is no free reducing end. There is no free anomeric carbon. That's why it is known as the non-reducing sugar. There is another example for non-reducing sugar, and that is nothing but the trioses. You can also learn this particular name, trioses, where two glucose units are linked with the alpha 1 and alpha 1 linkage. So glucose unit, the first glucose alpha, second glucose also alpha, and both will be linked in 1,1 linkage. Okay, that is what meant by the trioses. This is also a non-reducing sugar because we can see that from both components the first carbon is involved, so there is no free reducing end. Okay, so keep in mind sucrose and trioses are the non-reducing sugars and both are disaccharides. Now let us see the bond formation example. Sucrose, let us see the sucrose bond formation. You can see that the glucose is here, so this is alpha glucose and this one is beta fructose. Here the hydroxyl group, oxygen of fructose, will be making bond with the carbonyl carbon or the anomeric carbon of the glucose. As a result, water molecule will be released. And this structure is actually the sucrose. Keep in mind, when you are drawing, if you are drawing with understanding, you will be having confusion in this. If you are drawing with by hearting, you will not have any confusion. But make sure that you are drawing with the understanding what you are doing. Okay, so in this figure, you can see that I have taken the second. Normally, beta glycosidic bond, we will be having configuration like this or in this way. But you cannot see that here. It is a normal looking like a alpha configuration. How we can draw in that way is nothing but this is a normal fructose, okay, which is in alpha configuration. This is in beta configuration. Okay, so let us see this particular thing. Beta configuration we have to just take it and keep this end in this way. Okay, take the second carbon end into the fourth carbon end. So you are just turning the fructose. So you have turned it. Still you can see that in beta OH is on top, but here you can find OH down. How? you can just now relocate everything. So you can see CH2OH, OH down. Here CH2OH, OH up. So what about this? This is the third carbon. Okay, so let us move to third carbon. Here also OH is on top, H down. But you can see that you have opposite, made it opposite. H is on top and OH down. So everywhere you can just replace, make it in the opposite way. So as a result you can appear beta fructose like this. Okay. So now you are linking. As a result you will be having that particular sucrose structure like that. Hope it is clear for you. So you have to keep in mind this is the normal alpha and beta fructose. This beta fructose you are just making into this beta fructose. For that you are just taking and pulling it in the opposite way. So the second carbon comes here. Now you are just changing the configuration at every carbon. Whatever on top you are just making it down. Whatever on down you can just make it a top. Okay, in this way you will be having beta fructose looking like this, and the bond will be looking like this particular. So sucrose structure is this. Okay, one more thing you have to keep in mind. There is no special topic of disaccharide in your syllabus. Actually, it is not there only because you are learning the glycosidic bond in details. So whatever the disaccharide that are appearing in the glycosidic bond, you should be thorough and you will be getting a 4-mark question explain about different disaccharides. So at that time when you are seeing the question, you may be thinking like it is out of syllabus. So don't think like that, because the disaccharides we are covering under the glycosidic bond. So disaccharide is there in your syllabus, but it is not mentioned because it is coming under the glycosidic bond. So keep that also in mind. Whatever the disaccharides that we are learning under the glycosidic bond, you should keep in mind, and you have to remember what is meant by the reducing sugar and non-reducing sugar. Now let us move to the fourth type of glycosidic bond, that is nothing but the beta alpha glycosidic bond. Okay, so let us see that. Okay, we can see the beta alpha glycosidic bond. From the name itself we can see that the beta alpha, the first carbohydrate will be, monomer will be in beta anomeric configuration, and the second will be in alpha anomeric configuration. Okay, that is what we mean by the beta alpha glycosidic bond. So beta alpha glycosidic bond is nothing but the covalent bond that is formed between two carbohydrate units, where the first carbohydrate unit is in beta anomeric configuration and the second one is in alpha anomeric configuration. So the best example is the lactose. We know that lactose is the milk sugar that is present. Okay, we can see the lactose there. So this lactose is actually composed of galactose and glucose, where the first carbon of beta galactose will be linked with the fourth carbon of alpha glucose. Okay, so linkage is beta 1,4 glycosidic linkage. So we can see that the first anomer, beta anomer, is nothing but galactose, and the second alpha anomer is nothing but the glucose, that together form the lactose. Now let us see the bond formation there. So this one is actually the beta galactose, and this one is actually the alpha glucose. So just remember the thing that we have already learned. What you find the difference between glucose and galactose? Just pause the video and find out the difference between alpha glucose and beta galactose, so that you can predict your own knowledge. Okay, just pause the video and then find out the difference before I am telling. Okay, so we can see that between alpha glucose and beta galactose, only one carbon difference is there. So you can see the fourth carbon. The fourth carbon here, the configuration is different. So you can see here the fourth carbon OH is on the left side of the molecule. Is below the plane now in the linear structure it will be on the left side of the molecule. And here we can see that it is on the right side. So what is the carbohydrates or the monosaccharides which differs in configuration only at one carbon except the penultimate carbon is called. We know that it is epimer. So what we can say? Glucose and galactose are epimers. Which epimer? We know that the difference is at the fourth carbon. Therefore, it is C4 epimer. So galactose and glucose are C4 epimers. Galactose and glucose are C4 epimers. So don't forget that. Now coming back to the beta alpha glycosidic bond. So you can see here the first carbon, that is anomeric carbon, it is in beta configuration. So OH is on top. That will be combining with this carbon will be combining with the oxygen of the hydroxyl carbon of the next unit. So this next unit is nothing but the glucose, which is in alpha configuration. We can see the OH down. As a result, water will be released. You can see the water released, H2O, and this bond is formed. So this one is actually the lactose. And this bond is nothing but the beta 1 alpha 4 bond. So that is the example for the beta alpha glycosidic bond. So that's about the different types of O-glycosidic bond. Okay, so we have learned from the beginning that the glycosidic bonds are of two types. What are they? O-glycosidic bond and the N-glycosidic bond. And in O-glycosidic bond we have learned four subtypes that are alpha glycosidic bond, beta glycosidic bond, alpha beta and beta alpha glycosidic bond. And we have learned a lot of examples for that, or disaccharides. All those examples you have to keep in mind. That question will be coming separately. So you can get the question to describe the glycosidic bond as well as to describe the disaccharides. So both are coming under the same topic. Okay. Now we are just moving into the second type of glycosidic bond, that is N-glycosidic bond. Okay, the second glycosidic bond, that is N-glycosidic bond. In N-glycosidic bond, we can see that it will be between carbon and nitrogen, and mostly it will be with the molecules other than carbohydrate. One content will be carbohydrate and the amino content will be the particular molecules which is other than carbohydrate. So the N-glycosidic bond is actually formed between carbohydrate and other molecules or carbohydrate derivatives. Okay, so you can see that this carbon will be mostly anomeric carbon, but at the same time you can have the carbon which is other than anomeric carbon. You will be seeing both the N-glycosidic bond where you can find both anomeric carbon and non-anomeric carbon are involved in N-glycosidic bonding. So I am just taking two examples in that way. The first example I am just taking is the N-acetyl glucosamine. N-acetyl glucosamine. We have just mentioned about this particular molecule. Do you remember what we have mentioned? It is nothing but there in the chitin. We know that chitin is actually the homopolymer of N-acetyl glucosamine. So many N-acetyl glucosamines are linked, and as a result chitin is formed. So chitin is homopolymer of N-acetyl glucosamine. So I am just showing how the N-acetyl glucosamine is formed by N-glycosidic bond between the carbon that is other than the anomeric carbon and with the nitrogen of acetylamine. Okay, so you can see it here. So first of all we need a glucose unit. So glucose unit is required. So we can just draw the glucose unit. I'm just drawing it black. So glucose unit, we know the glucose structure. Okay, glucose unit is required. H, OH, H. I'm just leaving it because it is at this particular carbon the acetylamine is linked to form the N-acetyl glucosamine. And then I'm just filling the remaining portion OH, H, H, OH, CH2OH, H. Okay, so this is the glucose. Now the acetylamine comes. We can see the OH here, OH here, and I'm just showing the amine NH2. The second H I am just drawing with the red so that you will understand how water molecule will be released. And then NH2, C double bond O, CH3. Okay, so this is water. So this is acetylamine and this one is glucose. So you can see that this particular HOH will be combining, and as a result what will be formed? The H2O will be released. So you can see here the H2O will be released out, and as a result the N-acetyl glucosamine is formed. You can see the structure here. I'm just drawing this portion only because the rest of the things you know it from there, from this particular region. So I'm just drawing that particular thing. So H, then NH, C double bond O, CH3. So this is actually the N-acetyl glucosamine, where you can see the N glycosidic linkage here between the second carbon and the nitrogen of the acetylamine. Okay, we can just fill the remaining portion of the glucose so that you can avoid confusion. HOH, OH, H, HOH, then CH2, OH, H. So this is actually the N-acetyl glucosamine, where you can find N-glycosidic bond here. Unfortunately, when I'm just watching the recorded video, I could find that I have drawn the chitin in a wrong way, or the N-acetyl glucosamine in a wrong way, even though I did not mention it. Actually, the chitin or the N-acetyl glucosamine contains glucose, that is beta. I have accidentally drawn it as alpha, so I'm just correcting it here. So if I'm taking the entire video again, it's as it is time limiting, I don't have that much time, and as a result I'm just taking this video and I'm just inserting in between. So when you are seeing towards the end, you will be seeing the alpha itself, but make sure that you are learning it in the beta glucose form. So I'm just redrawing the N-acetyl glucosamine with the beta glucose. So you have to learn that only, not the alpha glucose N-acetylamine. Okay, so you can just see here the glucose will be in beta configuration. So it should be OH should be on top and it should be down. And we can see that we have linked that particular N-acetyl glucosamine, that the acetylamine at this particular portion, the N, H, C double bond O, CH3. The remaining portion is correct only. Only at this particular point you have to keep in mind the glucose in N-acetyl glucosamine is in beta. It is actually beta N-acetyl glucosamine that is present in case of the chitin. Okay, so OH, H, H, OH, CH2, OH, H. So this is actually the N-acetyl glucosamine. So just focus this particular point. We will be using the same video that we have recorded previously, but in that also it will be given as HOH. So take in this way OHH, because the glucose present is beta glucose. Okay, so just continue with the same other video. Now we can see another N-glycosidic bond where anomeric carbon is involved. The best example is nothing but the nucleoside that we are learning. Okay, so nucleoside is there where N-glycosidic bond is formed between the anomeric carbon of ribose and nitrogen of the nitrogen base. Okay, so let us see. You know nitrogen base and all, I am hoping so. So we can see that the bond is formed between nitrogen base and ribose sugar in nucleoside through N-glycosidic bond where the anomeric carbon of ribose is involved. So you can see here. So first of all, ribose. So furanose ring is there, and we know that beta ribose is there in case of the this particular nucleoside, because we know that DNA contains beta deoxyribose. So I am just representing the nucleoside in RNA with the ribose sugar. So we have H, OH should be here. OH I am just drawing like this, and the remaining portion we can just fill. So HOH, HOH. Please keep in mind I am just drawing OH because I am just writing ribose, not the nucleoside that is present in case of the DNA. Instead it is RNA ribose. So CH2OH, H. So this is the ribose. Now this ribose will be combining with any one of the purine or pyrimidine, any nitrogen base. I am just taking purine so that we can draw in a single ring. Pyrimidine, so that we can draw in a single ring. If you are not remembering the purine and pyrimidine structure, you can easily remember it, and don't worry about it. You can just watch my video on how to remember the purines and pyrimidines. You will be definitely remembering purines and pyrimidines forever without any forgetting or any problem. Okay, you will not have any confusion after watching that particular video. You can just watch that particular video. So I am just drawing the pyrimidine so that we can make it faster. Okay, so this pyrimidine will be having nitrogen here and one nitrogen here. Okay, so we can draw any of the pyrimidine. It can be cytosine, it can be uracil, it can be thymine. As I am drawing the ribose, we have to just draw the either uracil or cytosine. Okay, so I am just drawing the uracil. So in case of the uracil, double bond O will be there, and here you can find another H. I am just drawing it with red because you can just find the release of water. Okay, and then we can see that H will be there, H will be here, and double bond O will be here. As you cannot put the double bond here, you can have it. So double bond here. So that's it. That's about the uracil. Okay, so we can see that this particular hydrogen and OH will be released out in the form of water. As a result, a link between this nitrogen and this carbon will be happening. And that is actually the N-glycosidic bond where anomeric carbon is involved, because we know that this is the first carbon and that is the anomeric carbon. So I am just erasing and drawing in the same position. So the bond between this bond will be linked with this particular ribose through this nitrogen. Now this one is N-glycosidic bond. This one is the N-glycosidic bond. And if you want to turn that nucleoside, this is the nucleoside, into nucleotide, what you have to do? You can just add a phosphate group here. If you are adding phosphate group here, it will be a nucleotide. Okay, I am just drawing nucleoside only because our target is N-glycosidic bond representation. So this is actually a nucleoside where you can find a N-glycosidic bond between the sugar unit beta ribose and the nitrogen base, that is uracil, that we have done that. Okay, so that's about different types of glycosidic bond. So you have to revise the entire video and make sure that you are learning it properly, so that you can easily write or easily get the 4 mark. You can easily answer that 4 mark question. It will be coming. So 2 4 mark question is coming under the glycosidic bond. First is just to describe about the disaccharides, and second thing is to describe about the glycosidic bond. So don't forget that. Hope everything is clear to you, and if you have any doubt, you can just make it in the comment box so that I will be replying it to you. Or if you need any portions it is not clear or drawing is not clear, we can just make a second video and we can upload it so that you can make it more easier. Okay, so whatever the video, the other videos that I have mentioned in this video, you have to watch that so that you will be thorough and you will be sound in biochemistry. So biochemistry is such an easy subject, it's not a tough subject. As you are seeing lot of structures, you will be finding it difficult only because of your thinking like that. Okay, if you are not thinking and if you are making it easier by understanding what is the structure, how the bond is formed, etc., it will be easier for you and you will never forget, and it is one of the paper that you can score full mark. Just like mathematics, if you are making it correct, it will be full mark. So don't worry, so it will be easier. So hope that particular lesson is helpful for you and enjoy the lesson. So we will be again meeting with another lesson. Thank you.